how would you make it so that each, if you look at these, just going to flip back a little. Here, these are mostly elliptical, because of the land that they're on. And you see how perfectly spaced together they are. Now there's two ways of, if I wanted to make 10 circles, 10 feet wide, over 100 feet. Bless you, thank you very much. There's two ways I could do it. I could have somebody hold my tape, and I could walk out 10 feet, put my stake in the ground, and then they move forward, and then we put our stake in the ground. But we have to deduct a little, sort of 12 inches for the gaps in between. And then I would move along my flat ground for 100 feet. Now if I'm an inch out on that flat ground, it's going to make a difference exponentially as I go along. The other way is that if I had a 100-foot tape, I could stake one end in the ground, run it out its entire length, and then move along and stake my position down. If I do that over uneven ground, I need more equipment. It's not easy. It makes it more difficult. The more you add to the complexity, the more you add to the time scale. Okay, so that's what we're looking at. In the vast majority of crop circles, I would say 90% of them or more are on uneven ground. Okay, scientific data that's been gathered. We've used a couple of different scientists. The predominant one is a man called Professor W.C. Levengood, who's based in Michigan. He's been examining the wheat and the soil samples that we've sent him for the past 25 years. And what he's found, sounds some amazing things actually, the plants themselves have been subjected to three types of energy, terrestrial energy, electricity, microwave, and the soil shows effects of magnetism. We can tell this by the elongated nodes that we find. The nodes are elongated, and sometimes there are expulsion cavities in the elongated nodes. So this suggests that the plants are rapidly heated inside for a very small amount of time, about 3.5 to 4 milliseconds, he estimates. And you can replicate this by putting a piece of wheat in a microwave oven, and what it will do is elongate. It will heat it up from the inside, it will elongate the node, and then if you keep it in for longer, it will create expulsion cavities to let the steam out, and any longer catch fire. So there is a short burst, it seems, of some microwave energy which is causing these plants to heat up and lay over. Electricity is being established. It's like a respiration rate. If you have an electric shock, there is a way of putting on a heart monitor and detecting that you've had some kind of electrical shock, and plants that we have in the same way. And the